In this video, we're going to look at how you can match given linear equations with lines that have already been provided to you on a graph. You'll notice I have three different lines, A, B, and C, and I have three different equations, 1, 2, and 3. A great place to start is quickly scanning through your graph to see if any are horizontal or vertical. And you'll notice right away that line A is actually horizontal. What this tells us is that the matching equation can only have one variable, and it must be a y variable. So equations 1 and 2 both have x and y variables present. Equation 3 only has a y variable, so that must be the one that matches up with line A. But we also need to show and prove that that's the case. So 3y equals 6. Well, if I divide both sides of my equation by 3, I'll be able to isolate my y variable. And that leaves me with y equals 2, which, if we look at our horizontal line, the value for y at all points is 2, matches up with my equation. Therefore, I know that graph A must be paired up with equation 3. So this equation is taken care of, graph A is taken care of. I only have to focus on these two lines and these two equations. Well, how do I decide between these two equations when they both have x and y variables, and I have these two lines to pick from? A great strategy that you can use is to choose one of the lines, identify a point on that line that is not shared by the other one you're trying to decide against, and write down the coordinates for that line. So I won't choose this point for two reasons. One, because it's on both C and B, and two, because it's kind of in a weird place on the grid. It's not really easy to come up with my y and x values for that. So a really great place to pick for my line B will be right here, because it crosses the x-axis at 3. So my coordinate at that point would actually be 3 and 0. So what I'll do with this now is take my coordinate, and I'm going to substitute those values into one of these equations, and I'll see if both sides of the equation work out to be equal. So let's just start with equation 1. You could do equation 2 if you wanted. It really doesn't matter which one you start with. So if we use 3 and 0 as our coordinate, the equation will work out to be, substitute in our y value for 0, substitute in 3 for our value of x, so negative 3 times 3 plus 2, and what this means is 0 equals negative 9 plus 2. Immediately now I can realize these two sides are not going to be equal because it's saying that 0 equals negative 7. So this coordinate is not on the line for this particular equation. So I know that equation 1 does not work for line B. Well, what if I tried it out with equation number 2? So if we choose 3 and 0 as our coordinate, will it work for this equation? Substitute in. 2 times 3 equals 0 plus 6. Well, 6 equals 6. So I know that this point must be on this line, or at least it works for this particular line. And because none of the other lines in this particular problem cross at that same point, then it must match up with line B. And therefore, by default, the equation number 1 must match up with line C. You know, some problems you would actually have to do a second point to confirm whether or not the equation matches with the line. But since this is the only line with this point on it, we know that this equation matches up with B.